talking about this whole tree is a reticular activating system. This is the reticular formation. This is what I'm saying. The reticular formation is a series of tracts running through the brainstem. The reticular activating system includes all of these radiations out to the cerebral cortex. We already know about most of these as far as protection of the brain. We know about the skull. We know about the meninges. We know about cerebrospinal fluid. Here's something we haven't talked about. The blood-brain barrier. This is an important one. What connects neurons to blood supply? Very good. Astrocytes. Find a picture in your book of an astrocyte. What page?
356.
356. Take a look on 356. Especially since I'm out of slides. Take a look at the astrocytes. Do you notice how the material that's going out from the astrocyte literally wraps around the capillary? It forms an impermeable barrier. It forms a tight junction. Let me see if the next set of slides talks about it. No, it does not, so we'll just have to wing it.
Wing it.
If you look at those capillaries, you see how they're wrapped up in material, connective material. Most of the time, capillaries have little leaky edges. In other words, stuff can squeeze out of them. But not here, not in the brain. The blood-brain barrier is formed by those little extensions of the astrocytes. It forms tight junctions. Remember talking about tight junctions? So the capillaries, the simple squamous epithelia in those capillaries in the brain form tight junctions and are wrapped up in connective tissue from the astrocytes. Here's the importance of that. By creating, this is the blood-brain barrier, by creating tight junctions in these capillaries, only certain things are permeable. In other words, only certain things can pass through the capillaries. What do you suppose can go out of the capillaries? No. Blood stays in the capillaries. Oxygen diffuses out. Matter of fact, about 15% of our entire body's blood supply goes to the head. We send a lot of blood to the head. So oxygen is one thing that passes the blood-brain barrier. Glucose is another. We have active sites on the capillaries that will transport glucose into the neural tissue. Do you realize that 50% of the glucose that you use in your body is used in your brain? 50% of your blood sugar is used by the brain. So the blood-brain barrier allows oxygen and glucose to diffuse through, but very little else. Some ions, it will allow water, but it sure won't allow infection. This is our barrier to infection in neural tissue. Yes?
Is that why whenever your blood sugar level is low or whatever, it makes you angry? Is because of your brain?
Well, hypoglycemia, low blood sugar, you can go into hypoglycemic shock, and here's the problem. If we start to deprive, if we have low blood sugar, we'll start to deprive the brain of glucose. I mean, it uses 50% of the body's glucose. So it doesn't take much of a drop in blood sugar. What starts to happen in hypoglycemia? First of all, you start to feel fatigue, and then you feel disoriented, and eventually you die. You go into what's called a glycemic shock or a glycemic coma. So it can